Here is the video on squares using Vedic math way. Video number 12 is a part 3 of 5. In this video, I discuss a method that computing squares using base number multiplications. Okay, let's continue here. The next section is using base multiplication method. Squares using base multiplication method. Let's continue here. From base multiplication. Let's continue. Sutra for squares is double the deviation, which might be deficiency or surplus, and put the square to. So this is the, in simple words, it's we are going to double the deviation and put the square to. Let's see how we are going to apply that. So example, 98 times 98, base is 100, deviation is minus 2, and when we say from double the deviation, left hand side is going to be 98 minus 2, which is 96. And from the square of the deviation, we get RHS is equal to minus 2 times minus 2, which is a 4. Okay, let's see where do we go from here. Okay, now if we want to explore the place value system, we need to get a 0, 4 instead of 4. 98 times 98 is 96, 0, 4. Base is 100, and the detailed version of this base multiplication was left hand side, which is 96, times the base plus the right side. Okay, so that 9604. Okay, so I need 2 digits on the right because base is 100, which has a 2 zeros. When we multiply by 100, when I multiply 96 by 100, I get 2 zeros. So this 4 on the right has to fit within those 2 zeros. That is 0, 4. Let's continue here. So 98 times 98 is 96 times 100. That's another form. Plus 4. Base times the left hand side. Let's some more examples here. 99 times 99 is 98 and 0, 1. So 98, 0, 1 is the answer. Okay, so let's continue that one. 80 and 80. Let's take a base of 100. 80 is deviation is minus 20, so it is double deviation. 80 minus 20 on the left and 20 times 20 on the right. Let's continue here. Let's square of the deviation here. So 80 minus 20 is 60, and then multiply by base of 100, it becomes 60 and it's 2 zeros, and 400 on the right is a plus 400. That gets me 6400. So 80 times 80 is 6400. Let's continue here. Need that we only need 2 digits on the right to exploit place value system. The leftmost 4 must be carried to the left hand side. Okay, left from the right hand side there are 400 here. The 4 must be carried to the left hand side. Okay, so it was 60 on the left, 400 on the right. The 4 get carried to the left, becomes 64. Okay, let's continue here. That's 103 times 103. So here's double the deviation. 103 was the deviation surplus plus 3. So we double that, become 106 on the left and 09 on the right. So 103 times 103 is 10609. Let's continue here. Let's do 999 times 999. It's a 998001. So here is the deficiency or deviation was minus 1 here. So we make it minus 2. Base was 1000. So make it 998. 1000 minus 2 is 998. And 001, which is the deviation, was minus 1. Minus 1 times minus 1 is a plus 1, and I need 2 more zeros because when I multiply 998 by the base 1000, I get 3 zeros, and this 1 has to fit in those 3 zeros. So that is a 3 zeros, 3 digits here on the right. Okay, let's continue here. So if I say 1015 times 1015, So 15 is deviation plus 15. Double that become 1030. Base is 1000. And on the right, it's a square of 15. 15 times 15 is 225. 3 digits. I need 3 digits here because 1000. When I multiply left by 1000, I get 3 zeros. And this 225 has to fit in those 3 zeros. So just fine here. So 1015 times 105 is 1030225. Let's continue here. Example 87 times 87. So let's consider base of 100. So minus 13 is the deviation. Double that, I get it. 100 minus 26 is 74. On the right, it's a 13 times 13, 169. Only need 2 digits on the right because base is 100. When I multiply 74 by 100, I have a 2 zeros, and this thing has to fit within those 2 zeros. So this one get carried to the left. So answer is to square up. Now we are going to do a proportional based numbers. We were so far using 1000 and 100 as a base, which are natural based numbers. Now we will consider some proportional based numbers. The sutra we stated before applies to numbers close to natural based numbers. Natural based numbers are 1, 10, 100, 1000 are on the fractional side 0 0.1, 0 0.01, etc. Let's continue here. With slight modification, we can extend the application to more squares. Okay. So for numbers close to a proportional based number, the extra step is after doubling the deviation, we multiply left hand side by proportionality. And this proportionality may be 1. That's what happens in the case of using natural based numbers. Okay, let's do some examples here. First example is 52 times 52. And here is the part we are going base number we are going to use 50. Deviation is plus 2. 52 plus 2, that's twice the deviation here, double, so become 54. And here is multiplied by proportionality because 50 is a 5 times the base 10. Okay, so we get 52 plus 2, 54 times 5 on the left. On the right, it is say 2 times 2, 4. Only one digit is allowed because 50 is 5 times 10, and base number 10 has a 1 0. Okay, so it's on the left, it's a 54 times 5, which is 270, and plus on the right, it's a 4. So it's a 2704. Let's continue here. So for 198 times 198, base is 200, which is 2 times 100, and deviation is minus 2. So double the deviation gets me 196. Multiply that with the proportionality 2. On the right, I get 04 here because base is 200. 200 has 2 zeros, and this 4 has to fit within those 2 zeros, and that's 04. Okay, so answer is 39204. Let's continue. Example 82 times 82. So if you take a base of 80, which is 8 times 10, deviation is plus 2. 82 plus 2 is 84, and multiplied by proportionality, which is 8. So 84 times 8 is on the left, and 2 times 2 is a 4. 4 on the right, and base number is 80 has 1 0, and this 4 has to fit within 1 0, so only one digit is required. So it is 6724. Let's continue here. 222 times 222, which is a base number is 200, deviation is plus 22, so double deviation get me 244 here, and here's a proportionality 2. So that's on left we have 488, on the right it's a 22 times 22 is 484, but I only need 2 digits on the right, so this 4 on leftmost 4 of the right hand side gets carried to the left. So answer is 49284. Let's continue here. Example, you can also do that. 222 times 222 is 4 times 111 times 111, and 111 is 12321. Okay, you can do either use a the sutra which is trying to do that is okay, that's using a proportional base numbers, or you can say that 111 by 111 is 1 2 3 2 1. This is symmetric here. Okay, 1 2 3 and 1 3 2 1. Okay, so one you can multiply that over here. 123 times 4 is 492. 21 times 4 is 84. Okay, you have already seen numbers like this before. 1111, times square of ones is 1 2 3 4 3 2 1, like that. Okay, and 5 ones is that, and so on. Example 2015 times 2015. So 2000 is base plus 15 is deviation. So double the deviation get me 2030. Proportionality gives me plus 2 times 2. And on the right is 225. 3 digits on the right is fine here because base here is 2000. 2000 has 3 zeros, and this 225 need to fit it within those 3 zeros. That's fine. So I get 4060, 225. 2015 times 2015 is 4060. 225. Let's continue here. Example 708 times 708. It's a base number. Proportional base number is 700, which is 7 times 100. Deviation is plus 8. So double deviation get me 716. Multiply by proportional to get me times 7. On the right, it's 8 times 8 is 64. I need 2 digits, and I have 2 digits here. So answer is 7 times 716 on left is 5012, and 64 on the right. Let's continue here. 396 times 396. So it's a base is 400. Deviation is minus 4. So it's a double deviation get me 392. Multiply by proportionality 4. 4 times 392 on the right. It's a 4 times 4, 16. I need 2 digits. 400 has 2 zeros, and this 16 has to fit within those 2 zeros. So answer is 1568, 16. Let's continue. Yeah, 4 times 392 is 1568, and this is 16 here. Let's do the exercise. 11 times 11 first exercise. 89 times 89. 99 times 99, and so on. Okay, some more. Here is the proportional base number: 22 times 22, 38 times 38, 76 times 76, 203 times 203, and some more. Yes, 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 continue. Let's discuss references here. My first reference is usually this Vedic Math Teaching Volume Manual, Volume 1, which is a elementary volume, and it's by Ken Williams. You can get that in PDF form for free and print form for purchase from vedicmaths.org. Let's continue here. We can get a Vedic Vedic Math by Bharati Krishna Tirtha Ji is the main reference on the topic. Vedic Math for Schools in 3 volumes by James T. Glover is a good reference, and Glover used these books in his school. Let's continue. And Vanda Singhal covered recent topics in her book. Let's continue. And figuring is the reference for the first section here. Okay? Figuring by Shakunta Devi, and it's actually is Figuring the Joy of Numbers by Shakunta Devi. Okay? That's it.